Today we're going to take a look at how we can use graphs to help us tell stories. Graphs are really informational. They give you all kinds of stuff. If you stop and actually look at the scales, the labels on them, the numbers, the patterns on the graph itself, and we can connect that to telling a story, if you will. And so we're going to start with an example here of 4 different graphs and 4 little stories. We're going to try and match each graph to each story. So I'll read through the 4 things and we'll see which graph goes with which. So we've got Bob. He quickly rides his bike to school, then waits for his friends. That's A. B. Sue starts walking slowly to school and then she runs the rest of the way. C. Chris runs to the corner, waits for his friends. They walk to school, then stand talking. And D. Sarah, she runs to her friend's house, has to run home for her homework, then jogs to school so she's not late. So how can I match these things up to my stories? Well, one of our big ideas way back when was the steeper the line, the bigger the rate. So if I look at lines and I think about them doing things like this, let's put this one in between here. Oh, can't do that. Put one in between. The steeper the line, the steeper the rate. I can actually get an idea based on the words being used how steep a line should be. Okay? If I'm riding my bike quickly to school and then I'm standing or waiting for friends, I'm looking for a very steep line than one that's not steep at all. I think it makes sense to say this must be A. And he bikes really quickly and then he just waits. He's not going anywhere. No time. Time is passing, but he's not moving. If we look at Sue walking slowly and then running, we're looking for something that has a very slow rate to start and then a really fast rate. In other words, one like this. And here's her walking slowly. She's covering some distance, but not very. It takes a long time. And then running really quickly, and she gets there. And you got Chris. He runs to the corner, waits, so it's not just standing still. Then they walk, and they stand around talking. Well, the one that makes sense for that is this one. Running, waiting, walking, standing. Of course, one that's left, D. Okay, she runs, so it should be steep. Has to run home. That's the only one that actually goes back to where she started from. And then jogging to school means not quite as fast as running. I think that makes sense, right? Running back home, and then jogging. Yeah, so by thinking about the words and what they mean in terms of rates, I can actually match up graphs, or think about graphs in relation to the idea of rate and steepness. All right, let's try another kind of story. The Math Emporium warehouse is open from 8 a.m. to 2 p.m. daily. At 7 a.m., the warehouse is empty until the first trucks arrive at 8:30. For the next 3 hours, the trucks unload continuously until the warehouse is filled to 100% capacity. After a half-hour lunch break, trucks arrive to take stock out to the stores. This continues until the end of the day and the warehouse is empty again. Graph this information. Okay, so what do we start with? Well, it's open from 8 a.m. to 2 p.m. Okay, so I know that something's going to happen between 8 and 2. At 7, the warehouse is empty. So at 7, I've got no capacity. There's no books in here. Okay. The first trucks arrive at 8:30, so nothing is actually happening until 8:30. Well, if nothing happens, that means I've got no rate. Nothing's changing. For the next 3 hours, the trucks unload continuously. Continuously means they never stop until it's filled to 100% capacity. So 3 hours from 8:30 until 11:30, we're going to be filling this warehouse. So I'm going to fill it all the way up to 100%. Yeah, it's got to be a line. Half-hour lunch break. What happens during the lunch break? Nothing. So until 12, I've got my line. Okay, after the lunch break, trucks arrive to take stock out to the stores. This continues until the end of the day and the warehouse is empty again. Well, what is the end of the day? Does it say on the graph? No, but back at the beginning it said it's open from 8 a.m. to 2 p.m. daily. So what is 2? This is a 24-hour clock, so this is 1 p.m. This is 2 p.m. That's where it empties. It's going to continuously empty And then for the rest of the day, it just keeps on going. It's empty. Nothing's there. So in this case, we had to take the story, interpret it to make the graph, kind of working backwards. And you guys to try one. See if you can do this one all by yourselves. And it's a multiple choice question. Aaron takes a walk during his lunch break. The graph below shows information about his distance from school and time. Which statement could describe Aaron's walk? So without even looking at the answers yet, I'm thinking about he's leaving school, he's walking away from school, he's standing around, and he's walking back towards school. And steepness, this is faster. This would be slower, so maybe running or walking, or running or jogging. This is standing still. This is away from school. This is towards school. Yeah, let's see if we can match one up. Does he walk towards school, stop, and then walk away? No. Doesn't walk towards school at all. In fact, he's walking away from school right after that. We know that. So let's look at C and D. What's the difference? He walks away from school, stops. They both say that. And then walks at a faster pace back to school or a slower pace back. Well, look at my line. It's steeper. We said that was faster, which makes sense. I think C makes sense because it says he's walking at a faster pace. All right, one more. This is kind of a big typical question. Okay, Bill's mother sends her to the corner store for milk and tells him to be back in 30 minutes. The graph shown shows the relationship between his distance from home and time. Let's fill in the table with information about Bill's walk. So I've broken it down into a table for us to make it a little bit easier. I've labeled them A to B, B to C, C to D, and so on. So what happens here? Well, Bill walks from A to B. How far is that? Well, he's gone from 0 up to 200 meters. How long did that take? Well, he's gone from 0 to 2 minutes. How do we find speed? Well, they give me a hint here. It says meters per minute. So if I take my meters and divide by my minutes, I get 100 meters per minute. Just it tells me to divide, right? That's what this sign means right here. In what direction? Well, my direction's towards the store. I know that because it says Bill's mom sends him to the store to get milk, right? Okay, our next section, B to C. So he's starting at 200 meters, and it takes him all the way to 500 meters. So how far has he gone? What's the difference between these two things? So that would be 300 meters. And that took him from 2 minutes over to 8 minutes. Notice we're doing the difference between our dots, right? That far. Kind of the up and over idea. Okay, so from 2 until 8 is 6 minutes. Okay, speed 300 divided by 6. He's going 50 meters per minute, slower, which if I look at the graph makes sense. The line is not as steep. And where's he going? Well, he's still going towards the store. So maybe you start off by running, and now he's jogging. Okay, let's do C to D. So from here, which is at 500, we're still at 500. So he's got no meters. How long did that take? Well, we started at 8, and now we're at 10. The difference between those. Well, speed is 0 divided by 2, that's just 0. And what direction is he going? It's not really going anywhere. What's happening at this section? He's at the store itself. Didn't move. Okay, and the last section, from D to E. He went from 500 meters, that's how high that one is, all the way back to 0. So that's 500 meters. How long did that take? We went from 10 to 14. So that's 4 minutes. 500 divided by 4 is 125 meters per minute. Which way is he going? Towards home. Okay. So if I really wanted to, I could turn this into a story based on the information about, oh, he's going towards the store at a running pace. He slows down, he jogs for a little while, 6 minutes. He's at the store for 2 minutes getting the milk, and then he runs home. And I can tell the story based on this table of information I've got in my graph. Okay, that's how we're going to interpret graphs. And the big table idea is one that's really valuable. It's helpful to organize things. We should also be able to look at our steepness of lines and talk about rates. The big ideas there. Give this sheet a try, and if you're stuck, come see me.